Still on functions, but now I want us to look at what we call parabola in more details. Let's say you are given f of x here equal to x squared. Then the question says sketch this graph. Obviously, if you want to sketch this graph, you can use the table method. Right, let's put negative 2 here, 0 and 2. So if you put negative 2 there, this will be positive 4. If you put 0, this would be 0, obviously. Putting 2 squared, that would be 4. This means our graph would be something like this. Here you have 2, this is 2, this is 4, this is negative 2. Now negative 2 maps 4, which means here is your point, 0 and 0, and 2 maps positive 4 again, which means your graph will be something like this one. Obviously this is your parabola, which is f. Let me indicate the point here. This is 2 and 4, but this side, this is negative 2 and positive 4. This is a function of f. Let's say now the question says, throw the inverse of f. For the inverse, what do? We said for the inverse, you simply interchange x and y, which means now this point will be 4 and 2, but this one will be 4 and negative 2. Obviously, this is 0 and 0, but if you interchange 0 and 0, that will give you 0. Now, this means, if you look at this one now, here you have 4. This will be 4 and positive 2, which means the point would be here. And again, this is 4 and negative 2. This was 4 and positive 2. Let me indicate that one. 4 and 2. But this one would be 4 and negative 2. So it would be something like this. This is 4 and negative 2. Then this is 0 and 0. Then you simply join your points here. So basically this is what we call the inverse. And when you are asked to draw the graph, it is very important to also indicate the line of reflection, which is this one. We use a dotted line here. So this is a line of reflection, which is y equal to x. So this is just the graph of the parabola and its inverse. Now the next question can come and say, is the inverse a function or not? How can you test whether the graph is a function or not? You know what you do there. You use what we call a vertical line test. Vertical line test. This is from grade 10. Okay, if you want to test whether the function is an inverse or not. So if the vertical line test cuts the graph once, that will indicate that that particular function or that graph is a function. Let me draw the vertical line test here. Okay, this one touches this one once, and also this one touches this graph once. But now, if we look at the inverse, drawing the vertical line, obviously this line cuts this graph twice, which means the inverse is what? Is not a what? A function. Okay, that is what is important. Now, the question will say, give a reason why the inverse is not a function. Because it fails the vertical line test. Okay, that is simple as that. Okay, let me repeat. So as you understand, I'm saying here, or I said here, the first thing will be given this, and the question will say, sketch the graph of f. Obviously, you can use your calculator or use a table method. So this is our graph. Then if the question says, sketch the inverse, you simply interchange all the points that you have, then you join. Then our last question was saying, is the inverse a function or not? We said in order to check whether the graph is a function or not, we use the vertical line test. This is what we did here. So if the vertical line test catches the graph once, that's a function, but for twice, that indicates that the graph is not a function. Like this one, which is our inverse, it touches this graph twice, which means the inverse is not a function. Now the next question will come and say, how can you restrict the domain of the function in order to ensure that the inverse is a what? It's a function. Let's look at that. Okay. Right. Now the question says, how can we restrict the domain? We are talking about what we call restrictions. How can we restrict what? The domain, but this is a domain of what? Domain of f. So as the inverse will be what? Will be a function. Okay, let me redraw our sketch here. It was something like this. This one is a function, and this one is our inverse, and there is a line here which was y equal to x. Now there are two restrictions. The first one is to take where x is greater or equal to 0. Obviously this one will go with the inverse. Okay, this is a function. You only take the inverse where y is greater or equal to 0. Let me try to sketch this one. Right. This is your line, Cartesian plane. Obviously this is x, this is y. Taking your x greater or equal to 0, this will be your curve. Because this side from 0 to your right, your x is what? It's positive. And another one is where y is greater or equal to 0. Let's look at our inverse. We said from here to here, this is a positive section. And again, this one, this line, the curve indicate where y is greater or equal to 0, which means you would write this curve, because this curve, you know your y is greater or equal to 0. Now, if you can test whether the inverse is a function or not, obviously, if you draw the vertical line test, you can see that now the inverse is a what? It's a function. So if the question says, how can we restrict the domain of the function so as the inverse would be a function? Obviously, you would write the first one, which is x greater or equal to 0. Okay, now let's look at another restriction, which is the last one, because we said there are two restrictions. Okay, the second one, that is where x is less or equal to 0. This is a function f, but for the inverse, obviously this will be y less or equal to 0. Right, let me try to sketch that. Okay, here we are looking at whereby x is less or equal to 0. This is a curve. Okay, here we go. This is your f. But now, in order to indicate the inverse, obviously you take whereby y is less than 0, of which this is a curve. So it will be something like this. This one is a what? It's an inverse. Obviously your y here is less or equal to 0, but this side your x is less or equal to 0. So that is how one can restrict the domain. According to the equation for this inverse, obviously this will be y equal to negative, because we are saying y is less or equal to 0, negative root of x. But for this one, the upper one, it was the one whereby y is positive, the root of x. So basically that is that, and it is very important to indicate the line of reflection, which is y equal to x. Right, that's all.